Hey guys, sorry for the tardiness in this video. I can't believe I didn't think about it last night. We're going to be kind of referring to lesson 3-5 in your textbook, which is called Divide Multi-Digit Numbers. But really what we're going to, in that chapter, they kind of review problems that you did in 5th grade, and what they end up dealing with was, what if it doesn't go in evenly? And so they use this R to represent, oh, this is a remainder or leftover. Well, I'm sorry, but that is just not going to work in middle school. Today's date's 9/18. So I just want to go over some basics, do a couple problems, and call it a day. How about that? So first off, I'm going to demonstrate there are two basic ways that problems are traditionally presented to you that are division problems. It could be written horizontally with the division symbol, or it could be written vertically like a fraction. Okay. The one I want to focus in on, though, that we think about when we do long division, which is what we will do once we throw in the decimals, is it looks like this. Okay. So that division symbol actually kind of has a fancy name. This part here is called a vinculum. But it's not just used in division, it's used in other things in math. But it's a line that separates numbers from each other. So in this case, it's going to separate the number you started with the answer, and it's also separating it from the number that's going into it. Now, let's take and let's blow that guy up, and I'm just going to use variables. Okay, so variables are just letters. Actually, let's do some color. Let's get the division symbol, and we're going to do some color. Well, no, I'll do a math. We'll keep it this one. So 7 and 35 and 5. So each one of these parts of the division symbol or the division problem has a name. So what we start with is this guy underneath the division house. He's called the dividend. He's the number you begin with, and here's how I remember his importance. It will be the end of him. So when I do the division, it will be the end of 35. 35 will no longer exist as 35. The guy on the outside is called a divisor. And I'm exaggerating my pronunciation because he's like the supervisor of the division. So supervisor. So he's directing the problem. Okay? And then the answer is probably the weirdest answer to any type of math problem. The 5 is called the quotient. That's the answer to a division problem. So we're trying to figure out how many times does the divisor go into the dividend. Now, it could go in evenly, or there could be some leftovers, okay? But again, for our purposes, we're just going to focus in on doing numbers that work out beautifully. So remember in the last several lessons, we've been dealing with this notion of using estimation. And the question is, can we still use estimation when we're doing division? So let me give you kind of an example. And again, the whole point to do division, or estimation, is to get an idea of what the answer should look like. Is it going to be a 1-digit answer, a 2-digit answer, a 3-digit answer? Is it going to be in the 10s, 20s, 30s, whatever, okay? So we can use estimation is very helpful. So estimation, hello if I could spell today. Estimation helps understand if the answer is reasonable. So I'm going to deal with an idea called compatible numbers, compatible numbers. So let me just give you a couple of examples. So let's say we have 768 and we want to divide it by 8. Generally, I'm not going to round single-digit numbers, but this is where the rounding would occur. If I rounded 768 by normal means, I might round it to the nearest hundred and get 800. So I would get, that's about 800 divided by 8, which would give me about, 100. So my answer may be a 3-digit number, but again, I'm rounding up 768 to 800, therefore my answer would be below 100. Now, with compatible numbers, let me just write that guy down. So again, there's more than one way to do rounding and estimating. What I want to do is find a number that's compatible with 8 that's close to 76. Okay, so if I remember my multiplication facts of 8, I could say, well, 8 goes into 76. It would be about 772 would work. So what if I took this compatible number and rounded the 768 to 720? Now I've got a math fact to do, right? So this is estimated. And then I would get 8 goes into 72 9 times with 1 left over. So my answer is going to be somewhere around 90. Okay, so that's a different way you can do your estimation, is using this idea of compatible, especially if your divisor, that's the guy that comes after the division symbol, if he has a number close to the first couple digits of the other number. If it's a 2-digit number, then I may end up rounding both numbers. Okay, so and again, not a big deal. All right, so we can always estimate. So when I taught 5th grade, we used to call it the division dance, and the process goes like this. You first need to estimate how many times your divisor goes into the dividend. And we only are looking at chunk-sized pieces. So when I do a demonstration, I'll go over that. So we estimate, or sometimes your teachers would say you make a guess. So you're not looking for how many times does 8 go into 768. You're looking at how many times does 8 go into 76. Okay. From there, you multiply. So let's actually add to this. So this would be your estimate or guess would be number of times divisor goes into first 2 digits. Usually it goes into 2 digits. Sometimes it goes into 1 digit of dividend. Okay, and again, it's a lot easier when we go through an example. Then we're going to multiply, and what ends up getting multiplied is going to be the guess times the divisor. Now, by the way, where is this guess ending up? The guess will end up in the quotient. And then we subtract the product we just got from the first 2 digits, let's say, of the number we're dividing into. And then we're going to compare. Now, here's the crucial thing with the comparing. The difference must be smaller than the divisor. If the difference is larger than the divisor, then your guess was too small and you have to guess one higher. If your difference is too low that you can't bring anything down, then that means you're going to have a leftover, okay? But this is a process. And then you just go through and you repeat until you run out of digits. So just repeat. So let's do our two examples. And directions are going to say divide. So let's do that. Let's do that first one. Let's take 768. Let's divide it by 8 and see what we come up with. So I'm going to rewrite it with the division sign. The first number I see is the divisor. Take that back. The first number I see is the dividend. The number that comes after the division symbol is the divisor. So they kind of reverse roles when we put them under that quote-unquote division house. We did an estimate already on the other page, so I'll just kind of reiterate it. So we're going to get this is about 720 divided by 8, which give us about 90. Okay, so that gives us a ballpark. And so we just start working at it. So how many times does 8 go into 76 without going larger? So we would guess 9. And 8 times 9 is 72. Then we subtract. And then we have 6 take away 2 is 4. Oh, let me change color here. 6 take away 2 is 4, and 7 take away 7 is 0. Now this is where we compare. As long as my divisor is larger than my difference, I'm good. If the difference is larger than the divisor, it's bad. Okay? I didn't guess high enough. Now, one of the things I kind of didn't mention that actually squeezes in here, so I'm going to add him in just a slightly different color, is you are going to bring down the next digit in the divisor. So generally speaking, we are dividing into a 2-digit number is generally the process. So we have an 8 and we're going to bring it down. So now we want to figure out how many times does 8 go into 48. Well, that goes in 6 times exactly. So when I subtract, I have what's called no remainder. So the answer is that 768 divided by 8 is 96. Okay. All right, let's do one more. I want to do a double digit. Let's say we have 204 divided by 17. Okay. So when I set it up in the house, the 204 is the dividend. It'll be the end of him. And the 17 is the divisor. He's the one in charge of the division. So I am going to do some estimation here. 200, let's see, 17. We could do compatible numbers because 17 is kind of a weird one. We could round both of them. Let's try it this way. Let's round 17 to something like, I don't know, we could go to 20. And then we could say this is about 200. And so we should get an answer around 10. Okay? So we're going to get an answer somewhere in the neighborhood of 10. Now I rounded up on the 17 and down on the 4, so it's going to be someplace around there. So I'm going to go ahead and start. 17 can't go into 2, but it can go into 20 once. Oops, and then I write 17. I do my subtraction. I rename if I need to. This one I need to rename. Made a big mess. And when I do the subtraction, I get 3. Okay, 17 definitely bigger than 3. Bring down the next digit. And then how many times does 17 go into 34? Well, that ends up going in twice. Okay, so we're going to go ahead and put that in. We'll say twice, and we get 34. And then we end up go ahead and subtract, and we get 0. Okay, so that's dividing with long division. That's just long division for you, okay? All right, see you guys tomorrow.